Alright, ladies and gentlemen, in this video we are going to be looking at proofs with parallel lines, and specifically we are going to identify the converse of the alternate interior, alternate exterior, corresponding angles, and consecutive interior angles theorems. And we're going to learn that we use these theorems to prove that lines are in fact parallel. And then we're going to look at an example here to kind of show how we utilize these theorems. So let's start first and foremost with our corresponding angles converse. The corresponding angles converse is saying that if you can prove that 2 and 6, aka the corresponding angles, if you can prove that they are congruent to one another, then that's enough information to prove that the two lines are parallel. And so what I want us to really realize is that all of the converses for each of these four, they are used to prove lines are parallel. We use the original ones when we are trying to prove that the angles are congruent because the lines are already parallel. We are using the converses to prove that the lines are parallel. And so let's take a quick look at our other three converse to these three angle pair relationships. If we can prove that the alternate interior angles are congruent, then we can prove that the lines are parallel. If we can prove that the alternate exterior angles are congruent, then we can prove that the lines are parallel. And then last but not least, if we can prove that the consecutive interior angles are supplementary, then we can prove that the lines are parallel. Let's take a look at an example. In this particular case, we are given that R is parallel to S, and we are given that angle 1 is congruent to angle 3. Prove that P is parallel to Q. So what is very tempting here at times is just to think, well, 2 and 3 are alternate interior angles. Well, duh, they're going to be able to be worked. I can say that 2 is congruent to 3. Not yet. Remember, we don't know that P is parallel to Q, so we cannot use any of those theorems regarding alternate interior, exterior, corresponding, consecutive interior, based on the fact that P and Q are the parallel lines cut by the transversal. So let's think about what we do know for sure. We do know that 1 is congruent to 3 because it's given, but R is parallel to S and Q is a transversal to RS. And since R and S are parallel, I can make the claim that angle 1 is congruent to angle 2 because they would be considered corresponding angles if R is parallel to S and Q is the transversal. Well, now take a look at what happens. Now 1 is congruent to 3 and 1 is congruent to 2. Well, if 1 is congruent to two different angles, that means that those two different angles must be equal to one another or congruent to one another. Then I can say that my transitive property of congruency makes 2 congruent to 3. Well, now take a look at what we just did. Now we said that 2 is congruent to 3. What we were tempted to do in the beginning, we now said that 2 is congruent to 3. So what this tells us is that now we have alternate interior angles that are congruent. And if we have alternate interior angles that are congruent, I can use my alternate interior angles converse to prove that P is parallel to Q. And that is how we can utilize our converse of different situations.